All right, we're back for the last three examples. I started to do this one and I didn't like my notation, so I stopped and went back because I wanted to do the correct labeling. So this example 4 says h of x equals cosine of 4x squared minus 1 cubed. Find h prime of x. So here we have, let's do this. So our outer function here is cosine cubed of all this stuff, right? So to find h prime of x, I'm going to write on this line. The first thing I have to do is find the derivative of the outer function, right? Which would be to take the cubic to the front, the cubed, the 3, and this becomes cosine squared of 4x squared minus 1, right? Then I need to multiply it by the derivative of the inner function. Well, what is the inner function? The inner function here is the derivative of cosine 4x squared minus 1. Right? Because the outer function really here is this x. If you imagine like all of this is some variable, it's some variable cubed. It's all of this, which I don't know, let's just call that x. That means the outer function is really a cubic function. So the derivative of the outer function is just 3, all of this squared. Now the inner function is cosine 4x squared. Because remember, you could also rewrite this like this if this way is confusing to you. That's exactly how that's written. So all I did to find the derivative of the outer function is to take the 3 to the front, and then it's all of this still squared, times the derivative of what's inside, which is this. Okay, so now h prime of x equals 3 cosine squared 4x squared minus 1. And now what is the derivative of the inner function? Well, this again is a composite function because the outer function is cosine of something, right? And then the inner function is all of this. So I have to do the chain rule again. So this thing has 3 layers. I need to do the chain rule again. So let's do that. I'm just going to work this on the side here. So this becomes, well, what's the derivative of cosine? Negative sine of all the stuff on the inside. And then times the derivative of the inner function. What's the derivative of 4x squared minus 1? Just 8x. Right? So my derivative is actually this thing times all of that. Okay, so let's just rewrite it here because now I need to simplify. All of that times, which I could rewrite this as minus 8x times sine 4x squared minus 1, right? So we're really multiplying those two. So, I mean, I could do a little bit of simplifying. I could take negative 8x and multiply it by 3. So h prime of x is negative 24x. And then really we just have a cosine function left and a sine function left. So that is the chain rule, right? So you can keep doing the chain rule. It's like peeling an onion. You do the outer layer first, and you got to do the one after that and one after that until you get to the core. This one had 3 layers. All right, so now let's move on to example 5. Example 5 says, let f and g be functions such that f of 2 equals 2, f prime of 2 equals negative 3, g of 2 equals 4, g prime of 2 equals 6. Okay. If h of x equals g of f of x, then what is h prime of 2? So they're giving us a composite function and asking us to find the derivative of it. So we need to find h prime of x. So we're going to use our, we can actually use our definition for how to use the chain rule, right? H prime of x equals f prime of g of x times, oh, except our g and f is switched, so let me rewrite that. H prime of x equals g prime of f of x times f prime of x, right? The inner function. So now, if I'm finding it at 2, I need to find h prime of 2. That equals g prime of f of 2 times f prime of 2. All right, so h prime of 2 equals g prime of, well, what's f of 2? F of 2 is 2. From up there. times, what's f prime of 2? F prime of 2 is negative 3 times negative 3. So h prime of 2 equals, well, what's g prime of 2? Did they give us that? Yep, 6 times negative 3, that equals negative 18. Right, and then this one's fun because it's got a quotient in it, right? Y equals x plus 5 over x squared plus 2 all squared. Find y prime. So our outer function is just a squared function, right? So to find y prime, I first have to find the derivative of the outer function. So it's going to be 2 times x plus 5 over x squared plus 2, all raised to the first power, right? Okay, so I don't need to write that. Times the derivative of the inner function. So I need to derive this thing. Well, let's do some side work over here, because I know I'm going to need to use the quotient rule. Right? U equals x plus 5, v equals x squared plus 2. All right, so u prime is going to be 1, and v prime is going to be 2x. So remember the quotient rule is v prime u minus u v prime all over v squared. All right, so let's set that up. V prime u is 2x times x plus 5 minus u. I just wrote this the wrong way. Vu prime. Hopefully you guys caught that. So this is not right. Looking at my work, I'm like, wait, that doesn't make sense. So v times u prime. So v is x squared plus 2 times u prime is 1. Okay. Minus u times v prime. So that would be where this is. Right? All over v squared. So x squared plus 2 all squared. Okay, so now let's expand this. This becomes x squared plus 2 minus 2x squared minus 10x all over x squared plus 2 squared. So what we end up with is these can be combined, so we end up with minus x squared minus 10x plus 2 all over x squared plus 2 squared. So that is the derivative of this inner function. I used the quotient rule, right? So now I can come back and add that here. Minus x squared minus 10x plus 2 all over x squared plus 2 squared. So I could keep going with this, right? If you're doing this on the AP exam, you want to leave it here though, because then you're not going to have any arithmetic errors that can mark it wrong. But if it's multiple choice, this answer won't be there. You're going to have to solve it, right? Or simplify it. So you'd end up here with 2x plus 10, right, over x squared plus 2 times all of this. So really, I'm not going to write all that because what I'm going to do is this. I end up with 2x plus 10 times minus x squared minus 10x plus 2 on the top, all over x squared plus 2 cubed, right? Because this is x squared plus 2, and then this is x squared plus 2 squared. So I can multiply those out. So this, I'm going to leave it there. Okay, so chain rule, just, you're really doing what you already know. You just have to keep track of a lot more information, inner and outer function stuff. Okay, see you next time.